So for anyone who can't read, this is building Xamarin apps with the ArcGIS Runtime SDK for .NET. I am Rich Zwaap. I'm a developer on the .NET Xamarin Runtime team. Mostly work on Xamarin. I'm kind of the Xamarin guy on the team. As to what we're gonna go over here today, well, first, how many of you guys are already doing Xamarin development? Show of hands. Oh, not too many. How many of you are familiar with what Xamarin is already? Okay, interesting. Okay, so I'm gonna do a quick overview of what Xamarin is. Sounds like most of you guys are familiar, so I'll try to keep that brief. And then get into how Xamarin integrates with the runtime. Then talk about some Xamarin patterns and practices, dive in a little deeper and get into some more practical information, then some Xamarin tips. You may notice a common theme. You would be correct. This is a Xamarin session, all Xamarin, all the time. If you're not here for Xamarin, then you should probably go somewhere else. There will be some demos along the way as well. Those will be kind of interspersed with the patterns and practices and tips. So contextualizing this a little bit more, you guys may have noticed by now the runtime sessions are organized a little bit differently this year than we've done in years past, if you've been here in past years. With the release of 100, the Quartz release, we really are in sync across the board, across all our platforms, common architecture, common design, common functionality. What that means is we don't need to fragment our sessions up so much by specific platforms. Rather, we have a bunch of sessions that drill in on functionalities of the runtime. And we can do that in a platform agnostic way because those functionalities apply and the same development patterns apply across the board. That said, we do still live and work on different platforms in different development environments. Those offer different experiences. So for that reason, for each platform, we generally have one session like this, where we're gonna drill in on a specific development experience for a specific platform, in this case, Xamarin. So this session isn't gonna look so much at specific functionality in the runtime. There's gonna be some runtime coding, but that's not the point. The point is more how it applies, what the experience is for you guys as developers trying to code with Xamarin. All right. So Xamarin, what is it? It's essentially a set of software components to enable you to write cross-platform .NET and C# apps, right? Extending the reach of the .NET platform with WPF and UWP out to iOS and Android. In terms of software components, the binaries, the APIs that come with the Xamarin software suite, you can kind of break them up into three different parts. At the base, there is an open source .NET implementation for non-Windows platforms. That's Mono. That's the thing, the libraries you code against that give you all the familiar .NET base class libraries, all your familiar collection types, strings types, all that stuff. That's actually a pretty long in the tooth project. I think Mono started in like 2003. On top of that, you have what you can think of as platform bindings. And this is where I think Xamarin starts to become something really interesting and really differentiates itself from some other products. So these platform bindings essentially take the native operating system APIs for Android and iOS and surface those APIs in full fidelity for you to use in your in the comfy confines of your Visual Studio .NET C# development environment. let me say that again. All the APIs that are there for Android and iOS native developers are bubbled up to you guys through these platform bindings in C#. That's a really powerful thing. The third component of Xamarin's API surface is Xamarin Forms. So now with those platform bindings, you have a bunch of native UI components, right? So Android developers write their UI against different classes than iOS developers, than Windows developers. As Xamarin developers, you also have the option to do that through the platform bindings. But Xamarin Forms gives you a different option. Xamarin Forms is a UI abstraction layer on top of those platform bindings that let you write a UI presentation layer that can be shared across iOS, Android, and Universal Windows platform. So instead of writing your UI 3 different times, you can write it once and then reuse it across those different platforms. Moreover, it allows you to write your UI using XAML. It's not the same flavor of XAML as you'll see in UWP or WPF, but for those of you familiar with doing development using XAML, it'll feel very comfortable. It's easy to ramp up on. The same kind of conventions are there. Binding static resources, so on and so forth. So the other piece of the software suite, aside from the assemblies, the APIs that you get to code against, are the dev tools. So there's the development environments, Visual Studio, where Xamarin plugs in with Visual Studio extension, and then Xamarin Studio on the Mac, right? But additionally, as part of that, is all the stuff that goes on behind the scenes, that when you build your project, it just automatically from an Android project in Visual Studio goes and creates an Android application that is essentially the same as an Android application would it have been produced by an Android developer working in Android Studio. Same for iOS. That all goes on behind the scenes, but it's a really key part of what Xamarin is and why it's so useful. Beyond that, there's a bunch of other development productivity tools. There's the Xamarin Inspector for drilling in on your UI to see what's where. There's a profiler, and there's some other tools too that are useful for productivity. So what is it that you can actually do with this? I really already touched on this a bit. It's all about building .NET apps, cross-platform. .NET apps for iOS and Android, as well as Windows. Writing all your code using C#. F# is actually an option for any of you that may be interested in functional programming. There generally aren't too many, but you can write C# code, build apps for iOS and Android. All that code you're writing against the .NET libraries can be shared across all those platforms. But because of those platform bindings, if you need... Wow. If you need to get platform specific, if you need access to the camera feed, or you need access to the notifications API, which are different on different platforms, it's all there to you. So you can kind of interweave .NET and platform-specific code as you need for your specific purposes. And then the UI layer, you can either write cross-platform markup using Xamarin Forms, or you can get platform-specific and do a full fidelity native UI experience. So then what differentiates it? Why would you choose it? It's a cross-platform solution. Of course, a bunch of code's going to be reusable. If there was a cross-platform solution where code wasn't reusable, you'd wonder whether it was really cross-platform. But I think a key differentiating factor for Xamarin is all the platform capabilities are available. As far as I know, most other cross-platform frameworks work with some kind of abstraction layer, and it's not trivial to drill down and get at all the native platform capabilities. On top of that, and in part because of that, your UI components are shown with a fully native look and feel. So if you're developing your UI using the native API stack, it's actually instantiating the same classes. The operating system is instantiating the same classes under the hood, rendering them in the same way as it would for a native developer. If you're doing Xamarin Forms development, it does something very similar as well. As I mentioned, Visual Studio, C#. Also, there's quite an uptake with Xamarin. You can see there's a pretty decent turnout here, especially for a 5:30 session. But there's a lot of excitement out there about Xamarin. And just when I was setting up my demos, had to download Xamarin Forms a number of times. I noticed that the Xamarin Forms NuGet package is actually over 2 million downloads. So that's a lot. There's also forums out there, very active. And then as far as updates, so you're dealing with multiple platforms, iOS and Android, their release cadence is generally more rapid than we're used to from Windows. Xamarin's very good about picking up those changes quickly and turning around a new release that surfaces whatever new capabilities happen to be in the latest release of the underlying operating system. All right, so how does this tie in to the runtime? So let's take a quick look at what the architecture of the .NET SDK looks like. Of course, at the bottom, we have the runtime core, C++. If you've been to any runtime sessions, you probably heard all about it. That's where we have all the hardcore GIS functionality is implemented down there and shared across all our various runtime SDKs. On top of that, we have a managed .NET layer that we can share across all the platforms that we support as part of the .NET SDK. So for Windows platforms, for WPF and UWP, the .NET functionality capabilities are surfaced through the .NET CLR for WPF, .NET Core for UWP. And the classes that are common, that can all be shared across all our platforms, are basically most of what's in the API. So you see the list there: map, layers, symbols, etc. Tons of stuff. It says non-UI logic. There are objects there with definitely strong visualization components, map, layers, etc. But those can all be abstracted into essentially a specification, symbology, etc., that applies cross-platform. When we're talking about a UI layer, we're really talking about controls, things that where the rubber meets the road in terms of what you're displaying in an application, and that necessarily, for us, implementation-wise, has to get platform-specific. So there, we're talking about basically just the map view and the scene view. So there, our map view and our scene view, we have to inherit from different classes on WPF versus UWP, right? We have to do slightly different things under the covers. Where we surface members that are specific to the map view, like set viewpoint, etc., and scene view, we keep those the same across platform. But we can't do anything about the members we inherit. So that's where you'll ever see, pretty much ever see any differences in the API surface. Just in those two classes, and if we ever add any other view components. So that's the Windows platforms. So where does Xamarin fit into this? So at the .NET level, at the common .NET level, we're relying on Mono for all our .NET classes. Then we get up to the UI platform-specific layer, and we have map view and scene view specific to iOS and specific to Android. iOS, it inherits from UI view, Android, it inherits from view group. And then again, on top of that, we have our Xamarin Forms layer, where in Xamarin Forms, there's just one map view class, one scene view class, that can be used across UWP, iOS, and Android. And under the covers, those actually map to and use the platform-specific versions of those views that we have. All right, so what about specific capabilities for Xamarin in the runtime for .NET? In terms of the specific APIs we offer, we have the capability to code against the runtime using C# and .NET for iOS, Android, and Xamarin Forms. Xamarin Forms, in addition to iOS and Android, also covers UWP. Again, one common API surface. If you have code against our API, against runtime objects, you're going to be able to share that across the different platforms that we support as part of the .NET SDK. And then the rest, you essentially just get for free because this is a runtime SDK. So all the high performance mapping stuff that's a result of the C++ core being able to take full advantage of the device's hardware. Consuming all the services and content that come with the ArcGIS platform, being able to work offline. And of course, since we're building native apps and Xamarin bubbles up the native platform APIs, being able to take full advantage of the array of device sensors. Okay, let's dive a little deeper, get a little more specific as to how we're going to build our Xamarin apps and little things we can pick up along the way. So the first thing to be aware of in terms of patterns is MVVM, Model View View Model. Is there anybody here who hasn't heard of MVVM? Or how many people have heard of MVVM? Let's do it that way. Yeah, so if you're a .NET developer the last 5, 6, 7 years, you probably feel like you've been basically beaten over the head with this pattern. But it's important because this is the architectural vehicle that's going to facilitate reusing as much of your code as you can. Because if you're faithful to this pattern, it's going to create as clean a separation as you can between all your domain-specific business logic and the stuff that's really specific to surfacing functionality to your end user through the UI. But in addition to promoting reusability, there's a couple other side benefits. Since you're talking about having more granular pieces of functionality and less interdependencies between pieces of code by following this pattern, that's going to make it more maintainable. It's going to make it less brittle to, so you're not going to run into so many cases of changing code in one area and it has some unexpected negative consequences in another area because things are more encapsulated, things are more separated. And also because of that, the dependencies that are there become more obvious. Kind of related to that is testability. So you have your business logic, your domain-specific logic encapsulated into view models that expose properties and methods to actually leverage that logic, right? They're not being wired up to events from the view layer. So what that means is you can, in addition to wiring that stuff up to the UI, you can also separate it from the UI and invoke all that stuff programmatically. That means it's testable, right? So you get that just as part of following this pattern. So in the IDE, kind of coupled with the idea of MVVM and code reuse, we have something called shared projects. How many of you guys are familiar with shared projects? Okay, so there's a bunch of you guys that aren't too familiar. That's good. So basically, shared projects are in Visual Studio, in Xamarin Studio, they're a special type of project that act as containers for a set of code that's going to get linked in to other app projects or class library projects and be compiled as part of that project. The shared projects themselves aren't compiled on their own. They need to be linked into what you could call a head project that actually does the compilation and creates the binary. If you guys are familiar with linked files in Visual Studio, which have been around for forever, this is essentially linked files with much better tooling. Now, how many of you guys are familiar with PCLs, portable class libraries? Okay, a few. There is some debate out there about PCLs versus shared projects. In the case of the runtime, for code reuse, you have to use shared projects because we actually can't support PCLs with the way the runtime is architected and some of the limitations that exist with portable class libraries. We have heard from users on occasion that they would like us to support PCLs. Sometimes users have gotten a little, I guess you could say, attached to that idea on occasion. Sometimes with very good reason, especially third-party component vendors that themselves are trying to produce portable class libraries for others to consume. But there's also a lot of arguments around purity, and I think a lot of misunderstanding as to what shared projects can and cannot do relative to portable class libraries. So if you're getting into a discussion with another developer about shared projects and they say, whoa, no, you should be using portable class libraries that are way better, say, well, we should look into that a little bit because it's really not as clear cut. So what can shared projects do? They can share all your app code cross-platform. As I explained, you link sets of code into your application. Can be linked into multiple application projects. If I have an iOS application project, an Android app, and a UWP app, I can link the same project into all of those, and then all that code is getting reused in all those applications. Same thing with class library projects. I've got a screenshot here of some of our .NET API Visual Studio solution, kind of how we have that architected. And what you see here is we have an Android class library project, an iOS one, a UWP one, and a WPF one. So those are what build our Esri.ArcGIS runtime assemblies for all those platforms. And then below that, we have a shared project. And you see that's got a ton of stuff in it. The class library projects, they have very little in it because there's very little that we need to do that's truly platform specific. There's some map view stuff, there's some scene view stuff, there's a little location data source, listening to location update stuff, but very little. I would say it's got to be well over 95% of our code is shared across using the shared project way of doing things. Shared projects, this is kind of a misconception. They can co-mingle with portable class libraries. So if you're building an app and you want to use this cool portable class library, but you're also using the runtime, so you have a shared project that you're referencing, that's fine. You can reference both. What you can't do is if you're building a platform-specific class library or application, so you're building an Android class library or an Android application. It's not a portable class library. That cannot be referenced within other PCL projects. So that's where third-party vendors can run into issues because they want to leverage the runtime. They have a requirement or a desire to provide a portable class library to their users, and they're stuck in a catch-22 at that point. That said, it's a fairly niche case. All right, that's enough jabbering on. Let's actually jump into Visual Studio and see how some of this stuff works. Can people in the back see that font size okay? Yeah, cool. So here I am in my Place Finder solution. and I've got some app projects, one for Android, one for iOS. And here I have a shared project that has a view model, a class called MapViewModel. Very simple class for the moment. We just have an empty constructor. We have a map property. So this is going to essentially be the map that I want users to interact with in my application down in the UI layer. And then we have a property changed event to let the UI layer or let other subscribers know that something's changed in the state of the view model, right? So now what I want to do in this application is provide my users from a set of base maps that they can switch between. And I want to get that set of base maps from ArcGIS Online, from the base map gallery. So to do that, I'm going to need a base map items property that to surface that set of base maps down to my presentation layer. In this case, these are portal items because they're coming from ArcGIS Portal, ArcGIS Online. Online is just another flavor of portal. And then I also want a base map item property, singular, to track which from among the set of base map items is the one that's currently being selected. And then now notice in the setter here, after that's been updated, if the map in my view model's already been initialized, I'm gonna apply the new base map to that map immediately as soon as that property is updated. Now, since I am getting those that set of base maps from ArcGIS Online, that means I'm making a web request, right? So that's asynchronous functionality. I want to get those as soon as I instantiate this view model, but I can't do async calls from the constructor, right? So I'm just creating this little async initialize method to encapsulate the asynchronous functionality. And then I want to call that from the constructor. Now let me be clear, I am calling this asynchronous method here. When I say I can't do async from the constructor, I can't await asynchronous calls. I can't wait for that call to come back inside the constructor and then set the base maps. I have to pop that out to a separate method. So then in that initialization method, let me get that set of base maps. So here, I'm just creating a portal using a factory method. This is, since I haven't specified a URL, it's just going to be ArcGIS Online by default. And then this is a nice little easy way to get the base maps gallery from whatever your portal is. That's a new little nice piece of API at Quartz, this get base maps async call. And then I'm just updating the set of base maps with the returned results, right? Now that I've got that set of base maps, I want to set a selected one by default. So for that, I know I'm familiar with the base maps that are going to be coming back. I want to just get this one that has a title of a topographic. I know that's the world topo map. I also want to initialize the map with an extent that happens to be around the convention center. And then I'm going to take those two things, the extent and the base map, and initialize my map property so I can tell my presentation layer, hey, this is the initial map for you to display. All right. Let's jump back over to slides for just a minute. So I've got the back end set up for my initial map display and my initial set of base maps and which one's selected initially. So now I'm ready to start surfacing that up through the UI. So that begs the question, which way do we want to go? Do we want to do forms-based UI development, cross-platform, or do tailored user experiences for each platform and go native with it? Pluses and minuses to everything, right? So with Xamarin Forms, the obvious really good thing is you more or less get more bang for your buck. You get 3 platforms, iOS, Android, and UWP, for the price of 1. I say more or less because invariably you have to do an exception here, an exception there, because something behaves just slightly differently on one platform or another. So it's maybe 3 platforms for the price of 1.5. Like I said, it's a XAML-based UI stack, so it's a nice, familiar paradigm for all you XAML devs out there. The components, even though you're specifying them the same way across all these 3 platforms, they don't look identical across all 3 platforms. If you have a drop-down box, a picker on iOS, it looks like an iOS control. On Android, it looks like Android. Now, the things that are not so great is in some places, there is definitely less polish in the Xamarin Forms controls than you're going to get out of the native UI stack. There's just really no dressing that up. I mean, it's understandable. Doing a cross-platform UI abstraction layer is a monumental undertaking. So there are some places where it can use a little dressing up. Now, generally, you can massage the UI and make it nicer, but then that's additional tweaking that you need to do as you go along. The set of components you have in Xamarin Forms is not as broad as what you get from the native operating system UI stack. Again, it's an abstraction layer, so it's a subset. Now, drilling into the native side of things. So if you leverage the iOS UI stack, and you leverage the Android UI stack, and you leverage the UWP specific version of XAML, you're going to get a 100% full fidelity native user experience. It's more work, but that's the payoff for it. You have everything that a native developer has available to them at your disposal in terms of putting together a UI. And as a bonus, as you're learning about UI stack panels on iOS and relative layout on Android, those are classes that exist for Android developers and for iOS developers, so you're learning about their world at the same time. In fact, it's not uncommon when I run into a question when I'm doing some native UI development, I'll pop out to the Apple's iOS doc or Google's Android documentation because they're the same objects. You have to, learn to read Java, which is a lot like .NET anyway, or learn to read Objective-C, which is harder, but it's still pretty much the same stuff. Now, not so great, you're going to be writing a separate presentation layer for every platform. Presumably, your app is going to want to offer similar user experiences, at least in terms of the functionality. So basically, you're going to have to rewrite that similar user experience, either you or in conjunction with other people, for as many platforms as you're supporting. Aside from the upfront cost, that means there's more pieces to maintain long term. Additionally, the UI stacks that we're dealing with here are very different. I think they're very different. It would have been nice if they had borrowed from one another a little more along the way, but they didn't. So that means up front at least, the learning curve's steeper if you're going to go that route. All right, so for the space of this app, I want to show Xamarin Forms just to give you an idea of kind of the cross-platform UI capabilities you get with that. All right, so you may have noticed we already have this second shared project here. So this is a shared project specifically for my cross-platform UI definition. So here I have a map page. That's all XAML. This should look, for all of you that know XAML, this should look very familiar. XML namespace definitions using the CLR namespace and assembly syntax. Xamarin uses something called a content page, but then you see here they even surface a grid object that has column definitions and row definitions, just like in WPF or UWP, right? Or back in the days of Silverlight. So our task here is to bubble up that base map selecting ability through to the UI here. So I'm going to first instantiate my view model. Just like in Windows development, I have the option to do that. I can just do that right in my XAML. I could do it programmatically as well. It's up to you. Here I'm just going to do it right there. Grab my map view, and here, so we have binding context, same thing as data context. For some reason they decided to call it binding context instead. Binding to the map view model. Now notice here I'm saying dynamic resource instead of static resource. In Xamarin Forms, this is a little tip, if you're binding to a resource that is expected to change at runtime and you want to pick up those changes, it has to be a dynamic resource, not static resource. You can specify static resource, but that's just going to get the values at the time of binding, and it's never going to check for updates. So there's my binding context, and then I'm taking the map from my map view model and plugging it into the map property of my map view. Now I want a base map switcher, so let me bring in a couple more little Xamarin Forms components here. So here I have a label that's text block by a different name. And then picker, this is essentially a drop-down list or a combo box. And again, here I'm using binding. I'm binding the context to my map view model. I am setting my item source to my set of base maps. I'm setting the selected item to the base map item property on my view model and making that two-way so that when users interacting with my view select a new one, it pushes back up to the view model. And then the base map items, they're a CLR object. They're a portal item. They're not displayable in a UI. They're not a string or anything else that's going to make sense to display. So here I can say, hey, I have a property called title on my items, and I'd like you to use that to display in the list. So let's give this a run here. Let me make sure. Oh, come on. Now I can't dismiss the start menu, so that's always fun. There we go. Let me make sure my build settings. This will take a minute. Are there any questions so far? Could probably fit in one or two. No? Just want to sit here and watch it spin? Uh-oh. Oh, wrong emulator. Apparently I lost the emulator connection. So we'll just tell it to reconnect. Choose that guy. And try again. How many first-time Dev Summit attendees? Oh, a few, nice. Any fifth time or more attendees? Excellent. Any 10-time attendees? Oh, I feel like they should give out some kind of like award or certificate or something for that. That's an accomplishment. All right, so we're finally up and running. I have no base maps. I wonder if I have an internet connection on the emulator. I do not. That's unfortunate. All right, so here's a little troubleshooting tip. If your emulator loses internet connection, troubleshooting step number 1, always reboot, right? Oh, wrong one. No. There we go. All right, well that's spinning up. I can actually move on here. So now the thing you probably noticed most about that, when I just went to F5, it took forever, right? That's slow. So what are some things we can do to speed that up? Some of that, if you're deploying to Android or you're deploying to iOS, is the nature of the beast to some degree. So one really easy thing you can do is add a UWP version of your app. Even if you don't intend to ship UWP, especially if you're doing Xamarin Forms, it's trivial to just include a UWP version. And the build, deploy, debug cycle is super fast. Also, you saw I went in, made sure I was only building one platform at a time. Even though Visual Studio will do builds in parallel with as many cores as you have, it's still going to be dragged down by whatever the slowest one is. Now for iOS and Android, something you can do to help a little bit is use emulators for your day-to-day iterative development. I know some folks who do iterative development on devices. I suggest you don't do that. You, of course, should periodically check in with how your stuff is working on a device. And especially before you ship, make sure it's working on physical devices. But emulators are on the same physical hardware as your IDE. It's going to be faster to use them. Additionally, if you can, run the emulator and the IDE on the same operating system. Part of the slowness with my particular setup here for the demo, I'm actually running the emulator on the Mac side, on Mac OS, and I'm doing it from Visual Studio, which is on Windows. There's an additional copy that takes place there. So that means if you're doing iOS development and you want to keep iterating, you might actually want to take a look at using Xamarin Studio on the Mac. All right, so let's bring in a UWP project. First, let's see if our emulator's happy. You didn't see that. Internet. Maybe not. Oh yeah, it's going. It's just a nice fast internet connection. So let's see. I shouldn't have to do a rebuild and redeploy. The app's already on here, so if I just start it. Hey, there's our set of base maps. Loads. We've got the beginnings of an Android app. But we really need to do this faster, especially since I'm running out of time. So let's bring in a UWP project. I just so happen to have one lying around, imagine that. And this, what I'm bringing in is essentially an empty shell of a project. I just have my default main page. There's nothing in here. This has an element that's specific to Xamarin Forms for loading Xamarin Forms content into UWP apps. I do already have a reference to the runtime and to Xamarin Forms, but what I don't have a reference to is my shared projects. So here's the form shared project for my UI, the other shared project for my business logic, my view model, set this as the startup project, change my build settings, so I'm just building that guy, and run. And even though this is an initial build and deploy, it's still going to be a lot faster than with Android. And you're going to see that I have essentially the same app on UWP just by virtue of linking in the projects that have that shared code, right? That shared code and that shared markup. So same thing. And notice, even though it's using that same map page XAML, it looks completely different. This looks like a UWP app. The other one looked like an Android app. It just magically does that under the covers for you. It's pretty neat stuff. All right, so we want to build this out a little more as quickly as we can. Whoa. Okay. So I have my base map selection. What I want to do additionally is allow my user to search for places in the vicinity of where the current extent is. So for that, I'm going to cheat a little bit and bring in a mostly fully made view model that's going to surface that place finding functionality to my app. I'm just going to zero in on a few tidbits of code wire up here. So you see for the place finding functionality, we have a locator task. If any of you guys, how many of you guys have used previous versions of the .NET Runtime, 10.2.7 or other? Okay, a few. It's just locator task. It's not online locator task. It's not local locator task. This guy does both. That's something specific to courts. Also specific to courts, there's no constructor. There's an asynchronous factory task. The reason it's asynchronous is as part of instantiating it, it wants to go out and get the service metadata for you. And as a little bonus, it's at courts providing all that information to you. And that's a common pattern we have across our various tasks. Now, so when my user is typing in the name of a place to search for, it wouldn't be a modern app if it didn't have autocomplete, if it didn't give suggestions for places it might be searching for, right? So for that, as you saw in the plenary this morning, Courts has a new method for that, just the suggest async, and that's actually surfaced at the service level by the locator service. It has the ability to take a little bit of text, take some other specifications like how many results you want to get back, what the search area is, and say, oh, here's a list of things that the user might be looking for, and you can pop that up in your UI as suggestions for the user. And last but not least, when the user selects one of those suggestions, I want to actually then go and get the location for that place, right? So I'm going to ask the locator to do a geocode. That's nothing too special, except it's taking this suggest result object as part of the operation. The reason that's nice is it makes it really easy to get those suggestions back from the service. User selects one, and you just feed it right back into the geocode operation. You don't have to do any casting or any other funkiness there. So that's our back-end logic for finding a place. Now we want to feed that through into the UI. So we have a new view model here, so we want to instantiate that guy. And for the search box, there's this autocomplete view that's going to provide some of that autocomplete functionality very quickly. You see here the binding context is the find place view model. It's not the map view model. This has a suggestions property, binding that to a list of suggestions on my find place view model that are going to be populated after that suggest async call that it makes through the runtime. The text is bound to a search text property on the view model. And this is the mode's one way to source. So what that means is as my user types in text, it's going to push those updates back to the view model, not back down the other way. And then the view model is going to take that text, do a new get suggestions operation on the text as it stands so far. Then we have a selected item that's going to update when the user chooses one of those suggestions. That's going to go in the selected suggestion property on my view model. And again, that's one way to source because I only want that to come from the view up to the view model. Now, we've avoided it so far, but I am going to do a little bit of stuff in code behind. In general, when you're doing MVVM, you try to avoid code behind because it tends to be brittle. Sometimes it is difficult to get around. So in this case, I'm getting my view model from the collection of resources that I declared in the view. See over here, I'm declaring it in my resources. In code behind, I'm just grabbing it from the collection of resources. So I have it accessible in code. And then I want to listen to extent changes on my map view. And when the extent changes, I'm going to tell the view model that it's got a new center point around which to do a search. All right. So let's run this, see what we've got so far. Why that's starting full screen. So now, if I search for the Hyatt, I am not getting anything. Is it an internet problem? It's not an internet problem. Something is missing. All right, well, let's debug it. So when I type search suggestions, it's going to go into the search text property, right? And when that gets set, it does a call to get place suggestions. So that's happening. And let's see if it's actually getting those. Getting the suggestions. So why are they not showing up? Let's take a look at what I copied in here. Suggestions. Use label. Well, all right. Let's keep building this out. Maybe it was just a hiccup. Let's see. So assuming we'd seen the list of suggestions, we'd select one and nothing would happen at that point because we haven't wired up anything to happen once one's selected. So we want it to zoom to that, right? So here, back in code behind, wiring up to property change. Now, why am I wiring up to property changed? Let's trace it through. So when an item's selected, it goes to the selected suggestion property. Selected suggestion property then calls find place. It's saying, hey, a particular suggestion's been selected. Can you please get the particular geocode result that corresponds to that suggestion that's been picked? Ultimately, that goes and finds it and puts it in this place property. Place property fires property changed. So I can listen to property changed on the view model to see when there's a new place result, right? So let's bring in the implementation of that handler. And nope, still have breakpoints. That is very unfortunate. I'm not sure why those aren't updated. Let me try. So I'm going to try Android just to see if we're consistent across platform, or if something's gone wrong just with my UWP app. Well, I guess you know it's real if stuff's going wrong, right? While that's building, let me see. Wrong emulator again. Well, there are definitely network connectivity issues because it keeps losing the connection to my Android emulator. So that's fun. Let's go back and look at my steps here. Task suggestions. Well, I think we're going to have to move on. First, let's see what we've got here. Not working there either. So something's gone awry, but here I can move on to something else. See how the text is black here? So this is an example of what I was talking about where you almost get 3 UIs for the price of 1. Sometimes there's little issues from one to the other. So how do we deal with this? So we can say so this is in my autocomplete view. Don't know why that's still popping up. The text color on platform, so this is a Xamarin, a little hook that Xamarin gives you to differentiate between platforms declaratively in markup. On Android, I want it to be white. If I don't specify the others, it's just going to remain with the default. So, try that again. And now that we've seen the on-platform thing, we can look up here. Oh. Oh, it's going to start up before I'm ready for a change. So there, that's been fixed specifically for Android. So notice up here, I've got another on-platform. This is for the grid's background color. I want this nice dark gray color for Android, white for iOS, and UWP. It says WinPhone. That's a legacy property name. They didn't want to make a breaking change. It just maps to UWP these days. And reason I'm showing that is because we actually bind to that for the background color of this autocomplete view. And now this binding in particular is interesting because it's binding to a property on another element in the same view. It's binding to a property off of the grid. On WPF, you do something called element name binding. On UWP, you use something called xbind. I wanted to show you this because this is a common scenario, but the syntax is a little bit different. You specify the property name like you usually would, but then you specify the source as this X reference, and then the name of whatever the element is. So if we go back up to where the grid's declared, we see the name's root grid. So that's where that background background color is coming from. All right, let's jump back over to slides. All right, so yeah, getting into some specifics, little things to look for in Xamarin Forms, XAML, on-platform, dynamic resource. I just showed you the X reference, data templates. Let me show you this really quickly. Are you guys familiar with data templates? Show of hands? Couple, maybe? No? Not awake anymore? So Xamarin Forms XAML, you do have data templates, which is awesome because they let you very flexibly specify how a collection of items in a list are going to appear. I mean, you could put any kind of UI you want to in here, and that would show up in your suggestions if the suggestions actually showed up. But I'm sure you guys can use your imagination. The thing to be aware of is in Xamarin Forms, the root element of a data template always has to be view cell. I mention it because if you've done this much in UWP or WPF or Windows Phone or Silverlight XAML, it's going to be a common place to get tripped up. And generally, you don't get much very helpful feedback as to what's going wrong. It's just nothing shows up. All right, tooling. I'm going to go really quickly through these slides. The one thing I want to touch on here, are you guys familiar with the Xamarin iOS simulator that they released fairly recently? So basically, you can run an iOS simulator on Windows. Now, it has to be connected to a Mac, and it actually remotes to the Mac. But you can have your Android emulator, of course your Windows stuff, and your iOS simulator on the same box. And it supports touch, which is really interesting because on Mac, there is no touch. So it's actually, in some ways, better than running the simulator on the Mac. If you want to see that, we've actually got it running over at the .NET area. So just kind of wrapping up with the tips. There really is tons of resources out there. I didn't even mention here, I mean, forum support and the bug tracking system. I didn't even mention Xamarin University as well, which actually I meant to put a slide in there for us, but Visual Studio 2017 released today, and they're running a promotion where if you download it, I think before March 14th, you get a 60-day free trial of Xamarin University. Which they have tons of really useful resources as part of that. So definitely worth, I mean, you're probably gonna have to download it at some point anyway. You might as well do it sooner and get a free trial. Source code. So all Xamarin source code is available online. Just putting this demo together, I ran into a couple issues with some of their controls, things not working as I expect. Went into the source code, found, oh, this is what it's expecting. Very useful. Last but not least, the Xamarin stuff, it's not a silver bullet. It can be finicky. When it works, it's amazing. I mean, you're just going through slinging .NET C# code, running on multiple platforms. It's just puppies and sunshine. But then sometimes, for less than clear reason, things will not work well for a while. You need to get to the bottom of that. Now, I think it's telling that despite that, some people get frustrated with it and walk away. But despite that, there's a huge community and lots of companies have developed and released apps and continue to do so. And we're seeing the same with some of our customers. It hasn't dampened the enthusiasm, at least not that we've noticed. And presumably, with Microsoft having purchased Xamarin, one hopes that those issues will only continue to get ironed out along the way, because Microsoft's awesome at building stable stuff generally. So that's pretty much it. Here's a list of some other runtime sessions. Look quick, I'm not gonna leave them up long. On Friday, if you are still here then, the panel session is always good. Please, actually maybe I shouldn't ask you guys to fill out the surveys because my demo bombed, but no, seriously, fill out the surveys. What's that? It's a demo. Yeah. It is a demo indeed. It really couldn't be any easier. You're already using the events app to get around. Just open up the session, scroll down, and it's all right there. So that's all I've got. I know we're over time, but if anybody wants to ask questions, please feel free.